All right, good morning or good afternoon. We are going to start on section 10.3, which is dealing with an ellipse. Just want to make sure I cover a couple things here on your homework assignments. Remember, I'm going to post an answer key on Canvas so that you can access it, and you can access it the next day. So for today's assignment, you can start accessing it during class, and I would look that up at the very beginning of class. Check your homework, make sure you're doing everything okay, make sure you understand it. Well, something's going on here. And that was the actual lesson. Okay, well, I'll come back to that here, hopefully maybe a little bit later on. We'll see what's going on. For the ellipse, I think you know what it looks like. It's an oval. Okay, but we're going to come up with the equation of ellipse. We're going to graph the ellipse. We're not really going to translate ellipses. We're not too concerned about that. And we're going to also go some applications, but that'll probably be tomorrow. Okay, we're going to talk about the conic sections in terms of distance. We talked about circle, all the points the same distance from a fixed point, which is your center. We talked about a parabola, which is all the points that are equidistant from a fixed line and a fixed point not on the line. And now an ellipse is a set, is a set of all points x, y, the sum of whose distance from two distinct points is a constant. And those two distinct points are what we call foci, which is the plural of focus. So you had a focus for a parabola. We were going to have two foci for an ellipse. Now, just in general, we're just going to hit the equations right off the bat. If the center is at HK, okay, so this isn't center's not at 0, 0, it's at 2, 3, or negative 4, 1. The equation is going to look like this. It's going to be x minus h quantity squared over a squared. A is a constant, plus y minus k squared over b squared. B is another constant, equals 1. Or we flip. The only thing that's different here is the b and the a flips. A horizontal ellipse, sometimes people refer to that as a hamburger, okay, is wider than it is tall, and a vertical ellipse is taller than it is wide. The only difference is this a value is always the bigger number. A is greater than b, and if it's underneath the x term, it's going to be a horizontal ellipse. If it's underneath the y piece, it's going to be a vertical ellipse. Okay, it's going to be taller than it is wide. So that's just your general form. Now, some other key terms here. The a value. That a value is going to tell us. Now, a squared, okay, is that value when we take the square root of it. That tells us the distance from the center to the edge of the ellipse. Okay. The b value would be the distance from the center to the edge of the ellipse. Now, there are a couple of key things. These are your foci, the c values. They're always on what we call the major axis. Now, there are only two vertices in an ellipse. I know you're going to want to say there's four, but the only vertices are the ones that are on the major or the longer axis. So the foci, okay, which are your c values, and vertices. The vertices are going to be right here and right here. Both lie on the major axis. Now, the other axis we call the minor axis. Okay, that's going to be the smaller of the two. The major axis is going to be the bigger one, and then the minor axis will be the smaller one. Okay. When we double that length, so the whole length of the ellipse will be 2a, and the entire width will be 2b. Okay, so from the center to the edge. Now, if you go up here, if the center is at 0, 0, I'm just going to put this in here now. If the center is at, that's a 0, that's a 0. Basically, it will just simplify to x squared over a squared plus y squared over b squared. And it always equals 1. Same thing right here. X squared over b squared plus y squared over a squared equals 1. The only difference is where the bigger denominator is. Okay, and again, a is always labeled, or a squared is always labeled the larger number. Okay, when we're looking at the equation. All right, so that's your basic definition. All right, now I know this looks a little bit crazy, but I just want you to go understand how the foci and the distances between the two foci are related. So if you look at this, this is one foci, this is another. And we are saying for an ellipse, if you take any point on the ellipse and you add those two distances to the two foci, it's always going to be the same. So we'll call that D1 plus D2. Well, D1, the reason you see all these concentric circles, it allows me to count. So we'll just count these as 1 unit. So this is 1, 2, 3, 4, 5. So D1 is 5. D2, I'm going to start from this one, and I'm just going to go out every concentric circle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 5 plus 11 is 16. I'm going to make the claim that every point on this ellipse will have, I'm going to see if I can use a line, it's a little bit cleaner. Every point, if I take these two distances, it's always going to add up to 16. Okay, so if I take this point here and then I add this distance from here and then from the two foci, it's always the same. And actually, let me do this. Let me whoops. Let me flip it over to here so it's not so crowded. All right, so now I can count, and it should be 16. So if I count from here, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. And from this point here, 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 8 is 16. If I go back over here, 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it doesn't matter that value for this ellipse. Well, those two numbers will always add to 16. And then these are your two foci. And we'll get into a little bit more on their definition here in the next couple slides. Okay, the sum of the distances from the two fixed points will always be, we said, a constant. Well, that constant is always going to be 2a. Now, I'm just going to try and just do a real quick explanation of that. So if I take a look, if I go to, and I said any point, if I go to this point right here, then I got to add, okay, from this one right here, and then I got to add from this one right here. And if I add those two together, well, if you take a look here, A is going to be the distance from the center all the way to the edge. Well, this little piece here, and then this whole piece, that little piece there would connect to the end here, and it would basically go from end to end. Okay, so that's just a quick visual explanation of why that is the case, but it doesn't matter what point you pick. Okay, this distance plus this distance, D1 plus D2 has to equal 2a. Whatever the a is, you double it. And it doesn't matter where you do that on any point on the ellipse. Now, that next picture there, it says, what is the relationship between A, B, and C? Well, you've always learned in a right triangle, A squared plus B squared equals C squared, and that will never change. But this is an ellipse, And then in the relationship, I think it's already on your paper, but if it's not, that relationship is c squared equals a squared minus b squared. Okay, c squared equals a squared minus b squared. And so that is going to be the case that is always true. Let me just go through a real quick explanation of why. And I'm going to conveniently pick this point because what it does is it gives me two right triangles. And if you look closely, the distance here on that bottom leg is going to be C. This leg will be B. And then the same thing over here. This will have a length of C. So in this case here on the left, D1, using the Pythagorean theorem, D1 squared equals B squared plus C squared, which means D sub 1 equals the square root of B squared plus C squared. And over here, D2 squared equals B squared plus C squared. And D sub 2 will equal the square root of B squared plus C squared. Now, to kind of show you where that relationship comes from, we said from the last slide that D1 plus D2 has to equal 2A, always equals 2 times whatever A is. Well, D1 from there on the left is the square root of B squared plus C squared. D2, which is over here, is the square root of B squared plus C squared. Now you can add those two together, and when you do that, you get 2 square root of B squared plus C squared equals 2A. We can divide both sides by 2, get rid of those coefficients, and I get the square root of B squared plus C squared equals just A. Well, that still doesn't match what we said earlier. Let's get rid of the radical. Let's square both sides. So that gives me the square root of B squared plus C squared equals A squared. And I can just simply subtract B squared. And this is where we get that relationship. C squared is equal to A squared minus B squared. And we're not dealing with a right triangle. We're dealing with an ellipse, and we're dealing with the foci, okay? And we're dealing with the vertices, which are the A, and the endpoints of the minor axis, which would be your B values. Okay. All right, now this next one isn't on your guided notes. Just pay attention. All right, now how do we come up with the equation? I want to just go through that, the general form of that equation. Now this is wider than it is tall. Okay, this is wider than it is tall, which means it is a horizontal ellipse, which means it must have this general form. So that means it must look like x minus h squared over a squared plus y minus k squared over b squared equals 1. Well, our center is negative 2, 3. We need to know, okay, the length all the way to this will be one of the vertices, and then we need to know this length, which is the endpoint of the minor axis. Well, the first length is 1, 2, 3, 4, 5, 6, 7, and this is 3. That means B is 3. B is always a smaller value. A is 7. Well, for our equation, it is just going to now become x plus 2 squared over a squared, which is 7 squared, which is 49, plus y minus 3 squared over 3 squared, which is 9, equals 1. I just want to make sure you understand the relationship between the equation and what the graph looks like. So you take the center, which would be negative 2, 3, and that's your start. You find your A value. That tells you how far to go to the right. That tells you how far to go to the left. Those will be your endpoints of the major axis. you take the square root of those values. The square root of 9 is 3, so that means you go up 3, and we go down 3, and basically there's your ellipse. So just want to make sure a quick explanation of how to take an ellipse and find the equation, and then take the equation and find the ellipse. All right, this should be on your guided notes. So find the center, the foci. There's always two foci. And the vertices. There's always two vertices. Remember, the foci and vertices are on the major axis, which is the longer axis. All right, now you take a look at this one. You always had it over an a squared over a b squared. Well, if you see you just have an x squared, go ahead and just think of that as x squared over 1 plus y squared over 9 equals 1. All right, we said the a value is always the bigger one. The a squared is always the bigger one. So this, since it's underneath the y, that means this is going to be a vertical ellipse. It's going to be wider or taller than it is wide. And we say a squared equals 9, which means that a is 3. And we say that b squared is the coefficient or the constant underneath the other one. So it's going to be 1, and the square root of that is 1. All right, now I'm going to spread this out just a little bit so it's a little bit easier to graph. So I'm going to make that 1, make that 2, make that 3, and same thing over here. There's -1, -2, -3. And then I'm going to go up 1, 2, 3. And then I'm going to go down -1, -2, -3. Now I can graph it right now. Okay, it says in sketches graph. I got enough. Now, if you just have an x squared and you just have a y squared, that tells us the center is 0, 0. Now from there, we go, depending on where the a or the b is. Since the a is underneath the y, that tells us how far to go up or down, the square root of that. So we go up or down 3, and we put a dot. So there's my center. I go up 3, I go down 3, and since b is 1, I go left and right 1. All right, so there is, oh, this is going to be hard to draw for me. All right, there's our ellipse. Now we're not done because it says find the vertices and foci. All right, the vertices though are our endpoints on the major axis. So there's only 2 of them. It's going to be 0, 3, and it's going to be 0, -3. Okay, I do want you to find the foci and graph those. Show me where they are. They're always inside the ellipse. Okay, now we need to use the fact that c squared equals a squared minus b squared to find the foci. The c is the distance. Okay, the c is the distance from the center to each of the foci. Okay, so I need to find that distance. Well, c squared equals a squared minus b squared. Well, a is 3 and a squared is 9. B is 1, b squared is 1. And so we get c squared equals 8. So c equals square root of 8. All right, well, that tells us how far to go. And just checking there. And let me get my calculator out. Don't worry about, you don't need to simplify that, and I don't want it as a decimal at this point. So just find the square root of 8 to give you an idea, and that is approximately 2.8. So that means you have to go 2.8 from the center, and we're just going to mark it with like an asterisk. because it's not a point on the graph. And I'm going to go down 2.8 from there. Well, just to list the foci, it's going to be 0, square root of 8, and it's going to be 0, negative square root of 8. I don't even need you to worry about making it too radical too. I'm not concerned with you simplifying it. Just 0, square root of 8, 0, negative square root of 8. Sometimes they're really close to the vertices. There's just nothing we can do about those, but you need to make sure you identify where it's at. All right, so that's everything we need to find for that one. Center, foci, vertices, and then we sketched it. All right, let's take a look at the next one. Find the center, foci, and vertices for each ellipse and sketch its graph. Now, our center is going to be -3, +1. The a squared is always the bigger one. A squared equals 25 here. So that means b squared equals 4. That means a equals +5. That means b equals +2. All right, from here, I'm going to graph it. And let me see if I can do this. So I'm going to go to -3, 1. That's my center. A is 5. That tells me how far to go left and right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then B tells you how far to go up or down. So I go up 2 and I go down 2. Well, your vertices are along the major axis, which is the longer axis. So this point right here is one of my vertices, and this point right here is. So it looks like it is 2, 1, or I'm going to start with the smaller one. -8, 1, and 2, 1. Those are our vertices. Let me go back to the full. And I can graph it, and I'll do my best here. All right, not half bad. You still need your foci. Foci have to be somewhere along this major axis. Okay, that's the longer axis. Foci have to be somewhere on there. Well, we're going to use that fact again. C squared equals A squared minus B squared. Well, we don't know what C is, but the A squared is the bigger number. A squared is 25. B squared is 4. C squared equals 21. C equals the square root of 21. Just leave it like that. You do need to accurately graph it. So all I'm going to do is see what the decimal equivalent is. It's about 4.6. So I'm going to go 1, 2, 3, 4.6. Put a little asterisk. Same thing over there. All right, now to label those. The foci. Basically, you start at the center and you move to the right, square root of 21. So that is going to be the point -3 plus square root of 21. That is the x coordinate, comma 1. And it's all you have to do is list it that way. Just says I start at -3, I add square root of 21. The other one's going to be -3 minus square root of 21, 1. Okay. So we got all our facts. We got the foci, we got the two vertices, we got the graph, and then we got the center. Now, these 2 points right here, I said earlier, there's a tendency to want to call them vertices. Those are the endpoints of the minor axis. If they do ever ask for the endpoints of the minor axis, this is what they're referring to. The endpoints of the major axis are also known as vertices. So just an FYI there. Let's take a look at one more here today. This one doesn't look anything like the others. Okay, now, let me go backwards. We got to make it look. Now, on the homework, it doesn't necessarily, it asks for the center and vertices. You need to also rewrite the equation in this form here, the standard form. we need to make it look like one of these two equations, and it has to equal 1. Okay, so if you notice, both of these equal 1, and then we'll talk about that. All right, let's take a look at what we got. How do I take this? How do I make it equal 1? How do I make it look like a quantity squared? Okay, so like x minus 2 squared over 9 plus y minus 3 squared over 20 equals 1. So that would be an example of what we need to make this look like that. Well, anytime we come up with a quantity squared, we go back to our completing the square. We're going to have to do that. So kind of here's a little bit what we need to do. Get everything with the x together. So we get 9x squared plus 36x. Get everything with has a y variable plus 4y squared minus 24y. Get those together and then get any constants and take those and send them to the other side. So equals negative 36. So now I'm going to go through the process here of completing the square in a second. But we need to add something. And now anything I add on the left-hand side, I got to add to the right-hand side. We talked about this before. When you're completing a square, you cannot have a coefficient. So we actually have to factor this 9 out, and it becomes x squared plus, should be an x there, 4x plus, and then this is where we'll eventually add our constant. We have to factor this 4 out. It becomes y squared minus 6y plus, and then we're going to have to add a constant, equals negative 36. And then we're going to have to add our 2 constants here. Okay, you take half of 4, you square it. Half of 4 is 2. You square it, and you get 4. Don't forget this 9 is affecting this 4. So really, you don't want to put a 4 here. You got to put 9 times 4, which is 36. Half of negative 6 is negative 3. Negative 3 squared is 9. 4 times 9 is 36. So this is what it's going to look like. It's going to look like 9 parentheses x plus 2 quantity squared, because that's what that factors into, plus 4 times y minus 3 quantity squared equals. All right, got a lot of 36s running around here. When we are done, that whole thing just adds up to 36. Now the last kind of step, and if we go up here, you notice there's no constant in front of here or here, and it equals 1. What we're going to do is we're just going to divide by whatever this number is on the other side. And then it works out with our other cases here, because I'm going to get x plus 2 squared. The 9 and the 36 will cancel and leave me just 4 in the denominator. Plus, and this gives me y minus 3 squared. And then the 4 will cancel with the 36 and leave a 9 equals 1. So even though the directions in the homework don't specifically say it, you need to give me this equation. Okay, you need to come up with that equation and write it down. And then from there, we're going to get everything else, which means we got to find the vertices, we got to find the center, which were the directions here, center, foci, and vertices. And then we want to sketch the graph. Really, the graph is typically one of the easiest things you can get. And our center is negative 2, positive 3. A squared is always the bigger one. A squared is 9, which means A is 3. B squared is 4, which means B is 2. So I'm going to start at negative 2, 3. That's my center. Whatever the bigger number's under, that tells you that's going to be your major axis. So I'm going to go up 1, 2, 3. I'm going to go down 1, 2, 3. And I'm going to go to the left 2. I'm going to go to the right 2. And we can go ahead and sketch. Oh, I don't know if I can. Oh, Not my best. All right, so there's our graph. Vertices. Okay, those are on the major axis. That is going to be -2, 0, and it is going to be -2, 6. For the foci, got to use the fact that c squared equals a squared minus b squared. C squared equals 9 minus 4. C squared equals 5. So C equals the square root of 5. So we're going to move the square root of 5 along the major axis, and we're just going to get close to it. So it's 2.2. So I'm going to go up 2.2, a little asterisk, down 2.2. All right, well, I'm going to write in the coordinates. So I can say, so I started right here, and I moved in the vertical direction. So my x coordinate doesn't change. So it's -2, 3 minus square root of 5, and then -2, 3 plus square root of 5. There's our foci. Here's our vertices. There's our center. There's our graph. All right, we have everything it asked for. You got to be able to complete the square. You got to be able to convert it to this form, okay, in order to determine all the little details. All right, that's it for the first part of 10.3. Here is your homework. Make sure you graph these, okay? I think the first 5. The last one is not a graph. And then write the equation as well. It does not specifically ask for that, but you need to write the equation down. Okay, good luck, and hopefully I see you sooner than later.